All right, guys. So I am back talking about percent strengths. This is another concept that might be a little bit hard to get when you first start looking at it, but when you hear it explained, it makes a lot of sense. So percent strengths, all they have to do basically is when a solid ingredient, so this could be a salt, it could be a drug, it could be something solid, whether it's a powder or what have you, is put into a liquid product, and specifically with percent strengths, we're putting it into 100 milliliters of liquid product. So that's 100 milliliters of water, of oil, of any type of liquid that would dissolve this ingredient, which in many cases in pharmacy is either a drug or some other vehicle that would be used in compounding. Now, it's important to define two terms. We have our solvents and solutes. So a solvent, you'll see this thrown around. A solvent, that is our 100 milliliter liquid product. Solvents dissolve what is put into them. What's that's being put into them? It is a solute. S-O-L-U-T-E, solute. And the solute is that product that's going in there to be dissolved into the solution. You have a solute, a solvent, together they make a solution. Or sometimes a suspension, depends. I won't get too technical with you guys, but so our you'll see these, the main point of why I'm saying that, you'll see those terms put around. So they'll say you have X number of grams of solute. How much solvent do you need to dissolve that solute? But just remember, your solute is what gets dissolved. The solvent is what dissolves. Now, let's get started with our first practice problem. We have one, and between you and me, I don't really like how the book describes this problem, so I'm going to do it out my way and how I would approach the problem. Now, so I didn't write it down, but the question is, determine how much boric acid is needed to prepare 30 milliliters of boric acid 2% in 70% isopropyl alcohol. So we know that 70% isopropyl alcohol is the solvent. Now, this might trip you up, and they'll throw things like that, those details in there. But see this 70% isopropyl alcohol? That is a red herring. That is something that you don't have to worry about. That's just the classification for the concentration of isopropyl alcohol. For our purposes in this problem, it has nothing to do with this problem, right? So we might as well just cross that out so we don't get confused with it. We're just worried that it's isopropyl alcohol that is the solvent that we're using. Now, 30 milliliters of boric acid 2% actually gives us some useful information. So we know that 30 milliliters of boric acid 2%, we only have 30 milliliters of it. If we had 100 milliliters of boric acid 2%, we would have 2 grams of boric acid in that 100 milliliters of boric acid 2% solution, right? So it's 2 grams per 100 milliliters. That's what we know. So what do we do? Well, the answer is right in there. We set it up as a proportion. So we know as a percent strength, 2 grams of boric acid go into 100 milliliters of that total solution. What we don't know is our X. We don't know how many grams of boric acid go in to 30 milliliters of that prescription, that Rx that we're trying to fill, right? That total. So what do? Cross multiply. That gives us 100x equals 60. Solve for x, divide by 100, divide by 100. And then our x is equal to 0.6 grams of boric acid. And that is our answer. 0.6 grams of boric acid would be used to prepare 30 milliliters of that percent strength solution. Now, we can also, as I go to my other examples, we can also use this to approach example 11.8. Let me get a fresh piece of paper for you guys. As you look up example 11.8, that would be in, let's see, page 96 of your pharmacy calculation textbooks. And what we're going to do is we're going to do this example out for you right now. So this is still percent strength and stuff like that, but it just has a little extra step at the end for you guys. So let's go. You need to prepare 100 milliliters of hydrocortisone. I'm just going to abbreviate hydrocortisone HC. You need to prepare 100 milliliters of hydrocortisone, and it's a 20 milligram over 5 milliliter suspension, which is similar to a solution, just usually needs to be shaken up a little bit more, and you can usually still see the particles in there. That's a solution is usually transparent or clear, you don't see particles in it. Suspension, you can sometimes, it's usually a little cloudy. That's the main difference. Now, how many hydrocortisone 20 milligram tablets will you need? So we need to figure out X 20 milligram hydrocortisone tablets. How many do we need? Well, I like when I'm doing these problems to sort of write out everything I know, everything I don't know, and what I want to know. And I want to know how many tablets do we need for that. So step one, we want to calculate how much hydrocortisone is needed. And it's, in a very sneaky way, gives us exactly how to figure this out, because it's giving us the percent. Now, it's not a nice percent. It's not a very nice percent, because it's 20 milligrams of hydrocortisone in a 5 milliliter suspension. However, we can still set up our problem and figure out that percent strength. So 100 milliliters, because we know whether it's 5 milliliters or 100 milliliters of that solution, the ratio is going to be the same. How many milligrams of hydrocortisone would end up in a 100 milliliter solution? Well, let's solve for X. So 5X equals 2000. Divide by 5, divide by 5. And we get X equals 400 milligrams of hydrocortisone needed. Okay, so that's our first part of the problem, right? So we have 400 milligrams hydrocortisone needed total, but hydrocortisone, unfortunately, does not come, or maybe fortunately for patients, does not come in 400 milligram tablets. It comes in 20 milligram tablets. Remember up here? So basically, we can still use a proportion to just figure out how many tablets we need, because we know that one tablet is 20 milligrams of hydrocortisone, right? So how many tablets, X, how many tablets does it take to get to 400 milligrams of hydrocortisone? Again, we solve for X. 20X equals 400, because we're cross multiplying. Divided by 20, divide by 20. X equals 20 tablets of hydrocortisone. So that is our final answer for the problem. How many hydrocortisone 20 milligram tablets do we need? The answer, 20 tablets. And that is how you can use percent strengths to help you, even if you're not quite sure of what that problem might be or what it might be asking. It's quite easy just to break it down and figure it out. So thank you very much. And if you have any questions, as always, feel free to email